The most advanced warship ever built by human hands was also one of the most problematic. When the USS Gerald R. Ford finally deployed for the first time in 2022, it carried with it $11 billion worth of cutting-edge technology, 4,500 sailors, and a mountain of unanswered questions. This wasn't just another aircraft carrier heading out to sea. This was America's bet on the future of naval warfare, a floating city packed with experimental systems that had never been tested in real-world combat conditions. And as the world would soon discover, not everything went according to plan. The story of the Ford's first deployment is more than just a tale of mechanical breakdowns and engineering challenges. It's a window into how the United States military adapts, learns, and evolves under pressure. It's about the courage of thousands of sailors who volunteered to take an unproven ship into harm's way. And it's about the brutal reality that sometimes innovation comes with a price tag measured not just in dollars, but in reliability, readiness, and risk. Let me take you back to October 2022. The anticipation had been building for years. The Gerald R. Ford, designated CVN 78, was commissioned back in 2017, but it had spent 5 long years in various stages of testing, training, and troubleshooting. The ship was supposed to revolutionize carrier operations. It featured electromagnetic aircraft launch systems instead of steam catapults. It had advanced arresting gear to catch landing planes. Its weapons elevators used electromagnetic technology. The island superstructure was redesigned and relocated. The ship could generate 3 times more electrical power than previous carriers. Everything about this vessel screamed 21st century. But here's the thing about revolutionary technology. It doesn't always work the way you hope it will. And when you're floating in the middle of the ocean, thousands of miles from the nearest repair facility, that's when those problems become more than just inconveniences. They become operational nightmares. When the Ford left Naval Station Norfolk in October 2022, it was leading a carrier strike group that included guided missile cruisers, destroyers, and support vessels. The mission was clear: deploy to the Mediterranean and European waters, conduct operations in support of NATO allies, and demonstrate American naval power at a time when global tensions were running high. Russia had invaded Ukraine earlier that year. The geopolitical landscape was shifting rapidly. America needed to show that its military was ready, capable, and present. The crew was optimistic. Sure, there had been problems during testing and workups, but those were to be expected with any new platform. The engineers had worked tirelessly to fix issues. The sailors had trained extensively on the new systems. Everyone believed that this deployment would prove the doubters wrong. The Ford was going to show the world what American innovation could achieve. Reality had other plans. Within the first few weeks of deployment, problems began surfacing. The electromagnetic aircraft launch system, known as EMALS, started experiencing failures. Now, let me explain why this matters so much. On an aircraft carrier, the catapult system is absolutely critical. It's what allows fully loaded fighter jets to go from 0 to 165 miles per hour in less than 3 seconds. Without it, you can't launch planes. And if you can't launch planes, you're just an $11 billion target floating in the ocean. The traditional steam catapults used on older carriers like the Nimitz class were mechanical beasts. They were loud, they required massive amounts of maintenance, and they were hard on aircraft. But they worked. They were proven. EMALS was supposed to be better. Smoother launches, less stress on airframes, better for the pilots, more efficient, easier to maintain. That was the promise. The reality during this deployment was different. The system suffered from reliability issues that frustrated both the flight deck crews and the pilots who depended on it. Then there were the advanced arresting gear problems. This is the system that catches aircraft when they land on the carrier deck. Picture this: a fighter jet coming in at 150 miles per hour, hooking a cable with its tailhook, and going from flight speed to complete stop in about 2 seconds. The forces involved are absolutely enormous. The new EAG system was designed to be gentler on aircraft than the old hydraulic systems, reducing maintenance costs and extending the service life of the planes. But it too experienced reliability issues during the Ford's first deployment. The weapons elevators became another major headache. These aren't your typical building elevators. These are massive platforms designed to move bombs, missiles, and other ordnances from the magazines deep in the ship up to the flight deck. Speed matters here. In combat situations, the ability to rearm aircraft quickly can mean the difference between mission success and failure, between life and death. The Ford's 11 advanced weapons elevators used electromagnetic linear motors instead of cables and pulleys. Innovative? Absolutely. Reliable during this first deployment? Not as much as everyone hoped. Now, I want you to understand something important. The sailors aboard the Ford didn't give up. They didn't throw their hands in the air and declare defeat. These men and women are among the best trained personnel in the world. When systems failed, they troubleshot. When components broke, they improvised. When the technology didn't work as advertised, they found workarounds. The dedication and professionalism of the crew during this challenging deployment cannot be overstated. Captain Paul Lanzolata, who commanded the Ford during this deployment, later spoke about the experience with a mixture of pride and candor. He acknowledged the challenges but emphasized what the crew accomplished despite them. The Ford still conducted flight operations. It still projected American power. It still fulfilled its mission, even if not quite as smoothly as everyone had hoped. But let's talk about what was happening behind the scenes, because this is where the story gets really interesting. Back in the United States, officials at the Pentagon, naval leaders, members of Congress, and defense contractors were all watching this deployment very closely. The Ford wasn't just one ship. It represented a $30 billion program that included 2 more carriers already under construction, the John F. Kennedy and the Enterprise. If the Ford's technology couldn't be made reliable, what did that mean for the entire class? The Government Accountability Office had been raising red flags about the Ford program for years. Reports documented cost overruns, schedule delays, and technical problems. Critics in Congress questioned whether the Navy had rushed the ship into service before it was truly ready. Some argued that the Navy should have built one ship, tested it thoroughly, worked out all the bugs, and only then started construction on additional carriers. Instead, the Navy had begun building sister ships while the Ford was still working through its problems. Supporters of the program countered that this is how innovation works. You can't test everything in controlled environments. Real-world operations reveal problems that no amount of pier-side testing can uncover. They pointed to the history of American carriers. The first nuclear-powered carrier, the USS Enterprise, commissioned in 1961, had its share of problems too. The Nimitz-class carriers, now considered the backbone of American naval power, weren't perfect when they first deployed either. Growing pains were normal, they argued. The important thing was learning and improving. The deployment continued through the fall and into winter. The Ford operated in the Mediterranean, conducting exercises with Allied navies, supporting NATO operations, and maintaining a presence in strategically important waters. Despite the technical challenges, the ship demonstrated that it could perform its core mission. Aircraft launched and recovered. The crew maintained readiness. The strike group conducted operations that sent a clear message to potential adversaries. In December 2022, the Ford made a port call in Split, Croatia. For the sailors, it was a brief respite from the intensity of deployment. For observers, it was a symbol of American commitment to European security at a critical moment. The ship then continued operations, pushing further into winter in the Mediterranean. As the new year arrived, assessments of the deployment began to take shape. The Navy collected data on every system failure, every workaround, every lesson learned. Engineers from Newport News Shipbuilding, the company that built the Ford, reviewed the information. Representatives from the contractors, who supplied the various systems, analyzed what went wrong and why. This wasn't just about identifying problems. It was about finding solutions that could be implemented not just on the Ford, but on the Kennedy and Enterprise as well. One of the key lessons learned involved maintenance procedures. Some of the system failures occurred because maintenance protocols developed during testing didn't quite match the reality of sustained operations. The Navy realized it needed to refine these procedures based on actual deployment experience. This might sound obvious, but it represents a critical insight. You can write the best maintenance manual in the world, but until real sailors are performing those tasks under real operational conditions, you don't know if your procedures truly work. Another lesson involved spare parts. Some components failed more frequently than anticipated, and the ship didn't have enough spares on board. This led to delays in repairs and reduced system availability. For future deployments, the logistics planning would need to account for these actual failure rates rather than the optimistic predictions from testing. The electromagnetic launch system, despite its problems, also showed promise. When it worked well. Pilots reported smoother launches compared to steam catapults. The stress on airframes was indeed reduced. The system demonstrated that the fundamental concept was sound. What needed improvement was reliability and maintainability. Engineers focused on identifying the specific failure modes and developing fixes. By the time the Ford returned to Norfolk in January 2023, after approximately 3 months deployed, the crew had accumulated an enormous amount of operational data. This deployment wasn't the triumph that everyone had hoped for, but it wasn't a disaster either. It was something perhaps more valuable. It was a learning experience that would shape the future of American carrier aviation. Let's talk about the human element for a moment, because that's really what this story is about. The technical specifications and system failures are important, but they don't capture the experience of being a sailor on board the Ford during this deployment. Imagine being a young aviation ordnance man, responsible for loading weapons onto aircraft, and your equipment keeps malfunctioning. Imagine being a catapult officer, launching planes from a system that sometimes doesn't work right. Imagine being a pilot, trusting your life to technology that's still being perfected. These sailors dealt with pressure that most of us can barely comprehend. They were thousands of miles from home, working 12 to 16-hour days, maintaining constant readiness, all while knowing that the eyes of the world, or at least the defense community, were watching their every move. They knew that critics were saying the ship wasn't ready. They knew that some people thought the whole program was a mistake. And yet they showed up every day, did their jobs professionally, and made the mission happen. The deployment also tested the Navy's ability to support a new class of carrier. Supply chains had to be established. Training programs had to be refined. Technical support had to be available 24/7. The Navy learned that supporting the Ford required a different approach than supporting Nimitz-class carriers. This wasn't just a newer, fancier version of an old design. This was truly a new platform with unique requirements. After the Ford returned home, the work didn't stop. In fact, in many ways, it intensified. The ship entered a maintenance period where teams worked around the clock to implement fixes based on deployment lessons. The weapons elevators that had been problematic were modified. Software updates were installed in the MALS and AAG systems. Components that had failed frequently were redesigned or replaced. The Navy was determined that the Ford's second deployment would go more smoothly than its first. Congress held hearings about the deployment. Navy leaders testified about what went wrong and what was being done to fix it. Some lawmakers expressed frustration with the cost and schedule overruns. Others defended the program, arguing that innovation requires patience and persistence. The debate reflected a larger tension in defense procurement. How do you balance the need for cutting-edge technology with the requirement for reliability and affordability? The lessons from the Ford's first deployment had immediate implications for the other ships in the class. The Kennedy, under construction in Newport News, benefited from these lessons. Engineers incorporated modifications into the ship before it was even completed. This meant delays in the Kennedy's construction schedule, but it also meant the ship would be more reliable when it finally commissioned. The Enterprise, still in the early stages of construction, would incorporate even more improvements. One fascinating aspect of this story is how transparent the Navy was about the problems. In previous eras, the military might have tried to downplay or hide technical issues with a major new weapons system. But in the age of social media, congressional oversight, and investigative journalism, that approach doesn't work. Instead, the Navy chose relative transparency. Officials acknowledged the problems publicly while emphasizing the progress being made to fix them. This approach had risks. It gave ammunition to critics and potentially emboldened adversaries. But it also built credibility and allowed for honest conversations about the challenges of innovation. The defense industry paid close attention to the Ford's experience. Other programs incorporating similar technologies watched to see what lessons could be applied. The electromagnetic launch system, for example, wasn't just relevant to carriers. The underlying technology had potential applications in other areas. Understanding what went wrong on the Ford helped engineers working on completely different projects. Allied navies also followed the Ford's deployment with interest. The United Kingdom was building 2 new aircraft carriers, the Queen Elizabeth and Prince of Wales. France was planning to build a new carrier to replace the Charles de Gaulle. These nations looked at America's experience with the Ford as a case study in carrier modernization. What worked? What didn't? What would they do differently in their own programs? As 2023 progressed, the Ford continued its post-deployment maintenance and improvement cycle. The crew trained on the modified systems. Contractors completed repairs and upgrades. The Navy prepared for the ship's next deployment, scheduled for 2024. There was a sense that the worst was behind them, that the hardest lessons had been learned, and that the Ford would emerge from this process as the ship it was always meant to be. Let's zoom out for a moment and consider the strategic context. Aircraft carriers have been the centerpiece of American naval power since World War II. They allow the United States to project air power anywhere in the world without depending on foreign bases. They're mobile airfields that can steam to crisis zones and provide presence, deterrence, and if necessary, combat power. For decades, the Nimitz-class carriers performed this mission superbly. But those ships are aging. The oldest, the USS Nimitz herself, was commissioned in 1975. The youngest, the USS George H.W. Bush, was commissioned in 2009. The Navy needs replacements. The Ford class represents the Navy's plan for carrier aviation through the rest of this century. These ships are designed to operate for 50 years. The decisions made today about their capabilities, reliability, and cost will affect American national security for decades. That's why this first deployment mattered so much. It wasn't just about one ship having problems. It was about whether the Navy's vision for future carrier operations was viable. Critics of the Ford program often point to cost as the biggest issue. $11 billion for the lead ship is an almost incomprehensible amount of money. You could build hospitals, schools, and infrastructure with that money. You could fund countless other priorities. The question becomes, is a supercarrier worth that investment? Supporters argue absolutely. They contend that no other weapons system provides the combination of flexibility, lethality, and presence that a carrier offers. Opponents suggest that carriers are becoming increasingly vulnerable to modern missiles and submarines, and that the money would be better spent on other capabilities. These debates are important, but they sometimes miss a crucial point. The United States has already committed to the Ford class. 3 carriers are in various stages of construction or operation. The question now isn't whether to build these ships, but how to make them as effective as possible. The lessons from the Ford's first deployment directly inform that effort. One lesson that emerged clearly was the importance of realistic testing. The Navy tested the Ford systems extensively before deployment, but testing in controlled conditions doesn't fully replicate the stress of real-world operations. Going forward, the Navy recognized it needed to push systems harder during testing, creating scenarios that more closely matched deployment conditions. This would help identify problems earlier, when they're cheaper and easier to fix. Another lesson involved the pace of technology insertion. The Ford incorporated numerous new technologies all at once. Some worked great, others didn't. Future carriers might take a more measured approach, introducing new technologies incrementally rather than all at once. This would make it easier to identify which specific systems are causing problems and reduce the overall risk. The deployment also highlighted the importance of crew training. Even the best technology is useless if the people operating it don't fully understand it. The Navy invested heavily in training for the Ford's crew, but the deployment revealed gaps. Some sailors needed more hands-on experience with the new systems before deployment. Others needed better technical documentation. The Navy worked to address these training shortfalls, developing new courses and updating manuals based on deployment experience. Maintenance emerged as another critical area. The Ford's new systems required different maintenance approaches than older carriers. Some maintenance procedures that worked fine on Nimitz-class ships didn't translate well to the Ford. The Navy had to develop new maintenance philosophies, new schedules, and new techniques. This was time-consuming and expensive, but absolutely necessary for long-term success. As we approach the end of this story, or at least this chapter of it, it's worth reflecting on what the Ford's troubled first deployment really means. On one level, it's a cautionary tale about the risks of innovation. When you try to do too much too fast, problems are inevitable. On another level, it's a story about resilience and adaptation. The Navy didn't give up when problems emerged. It learned, adjusted, and pressed forward. The sailors who served aboard the Ford during that first deployment deserve immense credit. They took an imperfect ship and made it work. They maintained professionalism in the face of frustration. They represented their country with honor, even when the systems they depended on sometimes let them down. That's the human spirit at its finest. The engineers and technicians who worked to fix the Ford's problems also deserve recognition. They could have made excuses. They could have blamed each other or pointed fingers. Instead, they rolled up their sleeves and got to work. They analyzed data, redesigned components, rewrote software, and tested solutions. Their dedication turned problems into lessons and lessons into improvements. Looking ahead, the Ford's future deployments would tell us whether these lessons truly stuck. The ship deployed again in 2024, and by all accounts, performed much better. The systems that plagued the first deployment worked more reliably. The crew operated with greater confidence. The carrier fulfilled its mission more effectively. This progression from troubled first deployment to successful subsequent deployments isn't just a technical achievement. It's a testament to the U.S. Navy's institutional learning capacity. The story of the USS Gerald R, Ford's first deployment, reminds us that progress isn't linear. It's messy, complicated, and often frustrating, but it's also necessary. The United States military has always been at its best when it learns from setbacks and emerges stronger. That's exactly what happened here. In the final analysis, the Ford's troubled first deployment of 2022 to 2023 wasn't a failure. It was an expensive, sometimes painful, but ultimately valuable learning experience. It taught the Navy important lessons about testing, training, maintenance, and realistic expectations. It forced contractors to improve their products. It pushed sailors to excel under difficult conditions. And it reminded everyone involved that when you're trying to build the future, you should expect some bumps along the way. The legacy of this deployment will be felt for decades. Every carrier that follows the Ford will benefit from what was learned during those challenging months at sea. Future naval officers studying carrier operations will examine this deployment as a case study in how to handle the introduction of revolutionary technology. And the sailors who were there, who lived through the frustrations and the triumphs, will carry those experiences with them for the rest of their lives. The USS Gerald R. Ford today is a more capable ship because of what happened during that first deployment. It represents both the promise and the challenge of American military innovation. It shows us that building the future is hard work, that setbacks are inevitable, but that persistence and dedication can overcome enormous obstacles. That's a lesson worth remembering, not just for the Navy, but for anyone trying to push the boundaries of what's possible. Thank you for joining me on this deep dive into one of the most significant naval deployments of the 21st century.